Hello students, and welcome to my YouTube channel once again. Today we want to revise one of the topic concerning KCSE exam, especially for those who are candidates. We want to do a revision on one of the calculus topic called differentiation. Now, if it is your first time to come across these videos, like, share and subscribe so that you can be able to get the notification of the other videos. Now, dear students, today I want us to navigate through mathematics by looking at differentiation. Under differentiation, we will look at key points that are mostly set in KCSE exams, especially for those ones who are going to sit for KCSE 2026. Now, we will look at how to differentiate a polynomial. We also look at equations of normal and the tangent. In addition to that, we look at stationary points, also referred to as the turning points. And lastly, we will look at application of differentiation in kinematics. Now, to begin, first of all, we need to understand the term differentiation. Students, when you come across differentiation, what does it mean? Number one, we say that it's the process of obtaining a derivative function. We say it's the process of obtaining a derivative function. A derivative function. The process of obtaining a derivative function. What is a derivative function? A derivative function is also called a gradient function. Now, we already know what a gradient means. When we were in Form 2, we learned a topic called equations of a straight line. There we came across what we call the gradient. Now, then we can also say that a derivative function is also called the gradient function. The gradient function. Now, students, when we talk about differentiation, it simply means when we differentiate, it simply means we are going to obtain what we call a derivative function. Now, we need to navigate through and understand the process of differentiating. Now, how to differentiate now? Let us look at how to differentiate. It's very, very crucial. Given a curve, now let us look at one of the examples. We can have, like for example, x squared. Let's say x cubed plus 2x squared plus 4x. These are example students. Now, when it comes to differentiation, we have two very crucial and important points to note. That if you want to differentiate, number one, maybe this function, we say that y is equal to this. Now, this is our curve. We need to differentiate. Now, after the process of differentiation, we will come across what we call a derivative function. Derivative function, we say, student, is the same as gradient function. Now, how can we differentiate? We say that there are key points to note when it comes to differentiation. Point number one, we say that bring the power down. Bring the power down. That's the first process. Second process, reduce the power by 1. Reduce the power by 1. That's what we are supposed to note. That we bring the power down. After bringing the power down, we reduce the power by 1. Now, what does that mean mathematically? Mathematically, we need if we have x raised to n, then it means we will have nx n minus 1. That's what we mean. What are we saying? We say that if we have x raised to n, same as nx n raised to minus 1. So we bring the power down, then we reduce the power by 1. That's what we call differentiation. Yes, students. Now, considering that, we can now do that example dwelling on this. Therefore, let us do this. We have x cubed plus 2x squared plus 4x. Students, if we have such a equation, we say that the first step is to bring the power down. So when we bring the power down, it will be 3x. Then we reduce the power by 1, minus 1 plus. We bring the power down, so it is 2 times 2, it becomes 4x raised to 2 minus 1 plus. We bring the power down, here the power is 1. So when you bring down, you multiply by 4, 1 multiplied by 4, it becomes 4. So it is 4x 1, remember x is 1, minus 1. Dear students, I hope you are moving on well. Up to that point, we continue. Therefore, we have 3x, 3 minus 1, it is 2, so it becomes square, plus 4x, 2 minus 1, we get 1. Therefore, students, it is abnormal for you to put here 1. Raised to power 1, it is same as that letter. If we have x raised to power 1, it remains x. We don't put there power 1. Plus, we have 4x. Remember here you have power 1 minus 1. So it becomes 0. Therefore, x does not exist there. So this is our derivative. This is our derivative, or this is what we call our gradient function. Dear students, what is very crucial in this topic is to understand how to differentiate. There are only two very important concepts to understand. That we bring the power down. Then after bringing the power down, we reduce that power by 1. Very, very important. As we say that differentiation is the process of obtaining a derivative function. Now, this is our derivative function that we have obtained. Now, students, we have many examples in our KLD. We'll move there and do those examples. But let me do the last example before we move on to the next point. Now, part B, we can have x squared plus x plus 2. Given such an equation to differentiate, how can we do it? Come back, students. We're saying that for this case, it will be now x. We bring the power down, it will be 2x, 2 minus 1, plus. Here we have x. So if it is x, we say that when we bring the power down, it will become, the power is 1. So it is x, which is 1 minus 1. Plus, remember this one, we don't have the value of x. So it is not even necessary for us to differentiate. So we stop here. So here, students, it will be now 2x plus. Remember, 1 minus 1, the value of x will become 0. But remember, we brought down the power. So the power was 1. So it becomes 1. That's our gradient function or derivative. Now, students, that's how we differentiate. We need to understand this very crucial concept. Before we move on to any other bit, ensure you get this one very clear. Now let us move on to the next part of these important concepts of mathematics. Students, if you have not subscribed, subscribe, like, share, and comment. Now, we move on to another very, very crucial, very important concept. That's equation to normal, or we can say equation of normal and tangent. Equation of normal and tangent. Dear students, when we were informed to in the topic equations of a straight line, we talked about two types of lines. We have parallel lines and perpendicular lines. Now here, we are talking about the equation to the normal and the equation to the tangent. There's a very slight the relationship between these two things. Now let us begin by looking at the equation to the normal. Equation to normal. Equation to the normal. Now, dear students, when we talk about the equation to the normal, it is just the same as the equation to the perpendicular. When you talk about perpendicular, it means they meet at 90 degrees. That's what you call equation to the normal. Now, in most cases, we are given a question in exam, and they ask you to get the equation to the normal. Many students fail this question because they don't understand that equation to the normal is the same as equation to the tangent. Now let us do one example so that it can help us to build our understanding. So example number 1. Here we have what you call, say, we have an example here. Say that find the equation. Find the equation. Find the equation of normal 2 y is equal to x cubed plus 2x plus 1. In the bracket you have 1, 4. So this equation passes through the point 1, 4. The question says find the equation. Find the equation of the normal to this at this point. Dear students, let us move together. Now, here remember, if we have a point and a gradient is when we can get an equation. And here we don't have a gradient. We only have a point. And what we are being told here is that this equation is normal to this. So what are we supposed to do here, students? We differentiate this equation to get what we call a gradient function. After differentiating, we know that the coordinates are written in form of x and y. And here, this is the value of x. So on that equation, on that gradient derivative or gradient function, we will be able to replace the value of x so that we get the real gradient. After getting the real gradient is when now we will come back and find the equation to the normal. Now let us move that dy dx, we differentiate, we bring the power down, 3x, we reduce the power by 1, plus, we bring the power down, 2, here is x, so minus x is 1, minus 1 it will remain 2. This one, it does not have x. The value of x, though, there is no need for us to differentiate. So this is now our derivative, our gradient function. Therefore, dear students, we replace the value of x. We replace the value of x to get the real gradient. Therefore, students, we say 3x squared plus 2. We replace by 1, that is the value of x, plus 2. So we say that now gradient is given by 3, 1 squared is 1, plus 2. So our gradient, now students, now we have found our gradient, it is now 5. We say that if you want to get the gradient function, you differentiate the curve given or the equation given. Then after differentiating, you ensure that you replace the coordinate of x, the value of x to that to get now the gradient function. Get the gradient. Now after getting the gradient, this is a concept now we did in Form 2, that now after getting our gradient, we come back to our point. We say that we have a point, that is 1, 4, and our gradient. So we introduce another point with unknowns, and that is x, y. We say that gradient, we say that equation. For us to get the equation, we ask ourselves, how can we get the gradient? We say that the gradient is changing y over changing x. And we therefore say that change in y, y minus 4, over change in x, x minus 1 is given by 5 over 1. Now students, up to that point, we cross multiply, and therefore it gives us 1 into y minus 4 equal to 5 into 1 minus into x minus 1. Dear students, let us get that one very clear. We are still handling this question. Now, we've reached at that point, we say that that's y minus 4 equal to 5x minus 5. Now, after reaching that point, we can decide to write our equation in form of y is equals to mx plus c. But considering the demand of the question, if the question have not specified, then you can write in any form that you like. Now students, therefore it is y equal to 5x. This one moves on the other side, it becomes negative 5 plus 4. Therefore y equal to 5x minus 1. Students, this is the equation to the normal of this one at this point. Step number 1, if they ask you to get the equation to the normal, differentiate the curve to get the gradient function. After differentiating, now you have the gradient function. Replace where we have the value of x to find your gradient. Students, that's how we do questions concerning to the normal. Let us do one example that deals with the equation to the tangent. That deals with the equation to the tangent. Let's do one example that will show us the equation to the tangent. Now, students, say that the example says, given y equal to x cubed minus 3x minus 1. Say that find the equation of tangent. The equation of the tangent. Say that find the equation of the tangent to this curve. Now, dear students, when you talk about the equation of the tangent, it shares the gradient with the equation with the curve that we are having. The tangent, we can consider it shares the gradient. It acts the same as parallel lines. Parallel lines do share gradient. So, equation of the tangent also do share gradient with the curve. Therefore, dear students, the steps are just the same. Given the curve, we do differentiate. Say that tangent at point, let us complete our question. At a point, question at a point 1, negative 3. 1, negative 3. Dear students, given that equation, the steps repeats itself the same way. The first step is to get the derivative function or the gradient function. Now the gradient function we do differentiate dy dx equal to, we bring the power down, 3x squared, reduce the power by 1. Therefore we get 3. This one does not have any value of x, so it remains the same. Students, this is our derivative function. For us to get the gradient, we replace with the value of x, and therefore we say our gradient is equal to 3 minus 3. So our gradient is equal to 3 minus 3 is giving us a 0. So the gradient of this curve is 0. It means it does not have a slope. It is just flat. That's the gradient. Now after getting the gradient, students, we move on to get the equation. We say that if we have the gradient and we have the point, we can be able to get the equation to the tangent. Students, now we have a point 1, negative 3. You introduce another point with unknowns, x, y. Now we say that gradient is supposed to change in y over change in x. Now change in y is y minus 3 over x minus 1 equal to 0, 1. Students, after reaching that point, remember this is minus minor, the law of integers. When two negative signs follow each other consecutively, the summation amounts to a positive sign. And therefore, students, let us begin here. When we handle integers following each other consecutively. Now, if we have y minus 3 over x minus 1 equal to 0 over 1. So this is now equal to y plus 3 over x minus 1 equal to 0 over 1. So this is x plus 3 equal to 0 into x minus 1. Remember, when we multiply any number with a 0, we get a 0. Therefore, all of this will become a 0. So y plus 3 equal to 0. So this is our equation tangents. Yes, students? What is very important is to get a concept. You go in your math familiar and do questions. There you will get a lot of questions that will help you to do prepare for your KCSE in this crucial time that we are in. Now let us move on, students, to the next learning point of the day, and there we will talk about stationary points, or what we call the turning points. We will talk about stationary points or turning points. Stationary points, also called the turning points. Let's talk about stationary points. In example, we can also call it turning points. Students, when you talk about stationary, it's something that is at rest. And when you talk of stationary, in mathematics, a stationary point, the gradient of that point is normally 0. Here we have a curve like, we can have a curve like this. This is a turning. Let us make sure that we have that turning point very clear. So at this point, and at this point, where we have the turning stationary point, there we have the gradient of that point is normally 0. So very important point to note, students. Very crucial point to note when it comes to this. We say that note at stationary point, at stationary point, the gradient is normally 0. Normally 0. That is very, very crucial to understand. Very important. For you to answer any question concerning this, that is the beginning point to understand. Now, dear students, when you understand the gradient is 0, in most cases, these questions they ask you to get the stationary points. Then number 2 is state their nature. Those are the only questions that we normally get, and they amount up to 10 marks. Students, let us understand those things very well. Now, to emphasize on that, let us do a question that will help us to understand this one very well. Now, have an example here. The question says identify the stationary points and state their nature. And state their nature. Identify the stationary points and state their nature. Then you have been given the equation y equal to x cubed minus 3x plus 2. That's the equation that we have. State their nature. So the equation is in two forms. Number one, stationary points. Number two, state their nature. This question, the part of stationary point can amount up to 4 marks. Then that one of stating the nature can amount to 6 marks, giving you a total of 10 marks when they come to exams. So students, let us be very keen, very, very important. Now before we move on, if you have not subscribed, subscribe to this channel, like and share these tutorials so that you can be able to get a notification when we upload new lessons. Now students, it's very important for us to start doing this question before we go anything. Now, the question is to identify stationary point and to state the nature of those points. So, students, we go back to our key point that at stationary point, the gradient is normally 0. Let us go back to the beginning of our lesson. In the beginning of our lesson, we said that for us to get the gradient function, we differentiate any given polynomial or any given curve or any given equation. After differentiating, we get what we call a gradient function. Now, this is our equation, our curve, our polynomial. Now, for us to get this, to get the gradient of this one, we differentiate it. Now, the first step is dy dx. dy dx. So dy dx will be 3x squared minus 3. That is it. Because when we differentiate x, it will become 0. Therefore, we gain 3. This one, it does not have any value of x. So there's no need to differentiate. It will become a 0. Now, dear students, we have this as our gradient function. We know very well that the gradient function of stationary point is normally 0. The gradient is 0. So therefore we go ahead and say 3x squared minus 3 is giving us 0. At any turning point, at any stationary point, it is 0. And therefore we say that this move to the other side, you get a 3x squared equal to 3 over 3 over 3. X squared is given by 1. Square root. So x is equal to 1. Students, that's the first very important and very crucial point to understand. Now we have got the value of x. This is the value of x. But remember when we do the square root, we give in form of square root, we give in form of plus or minus. So therefore our answer will be plus 1 and x equal to minus 1. So we have two values of x. Students, we have the two values of x. Here we have the first value of x as 1, the second value of x as negative 1. Now after we have got the value of x, remember for us to talk about stationary point, it must be in coordinate form, in form of x and y. And here we have the value of x. For us to get the value of y, we go back to our curve, and our curve was y equal to x cubed minus 3x plus 2. We replace on that point, we get the value of y. So y equal to, when it is 1, we say 1 cubed minus 3 into 1 plus 2. So y equal to 1 minus 3 plus 2. So y equal to 1 plus 2 minus 3. So y equal to 0. That's the first value of y. The second value of y, we say that y equal to negative 1 cubed minus 3 into negative 1 plus 2. Students, When we cube this, becomes negative 1 minus negative 1 times negative 1, we get 3 plus 2. Therefore, students, when we say negative 1 minus 3, so it becomes what? Negative 1 minus negative 3 is negative 4. Negative 4 plus 2. So the answer is negative 2. That's one of our stationary points that we should be able to understand. Very, very important. Let us do a proof, because in maths we don't assume, we do things, we work with accuracy and so on. So students, this is giving us the value of y as 4. So we have the first value of y as 0, then the second value of y as 4. So that means that the stationary point, we have two stationary points. The first stationary point, we use x as 1 and y as 0. The second stationary point, we use x as negative 1 and y as 4. Students, that is very, very important to understand. Now, after reaching at this stationary point, you have around 5 to 6 marks. And that is the first part of the question. The last part of the question says, and find their nature, which is very, very crucial. Find their nature. And we only have three types of nature after getting that. Now let us finish this question before we come to the end of our lesson. Now, to identify the nature of these 2 points, we draw a table like this. Here we have the value of x, here we have the value of the derivative. Here we have where x, we use the 2 stationary points. We have 1, 0, then we have negative 1, 4. So we only dwell on x, and here we use x as 1. When x is 1, remember this at a stationary point, the gradient is 0. We also have another one, because there are 2. When the value of x is negative 1, then the gradient is 0. Now students, we need to fill this table. We go back by 1 step, then we go forward by 1 step. Now, when we go back by 1 step, we say that 1 minus 1. We go back, it is 0. Then 1 plus 1, it is 2. Here we also go back 1 step, and we go forward 1 step. So, minus 1, it is minus 2. Minus 1 plus 1, it is 0. Now, after getting that, students, we go back to our gradient equation. We don't go back to this, but we go back to the gradient function. So our gradient function was, we have rested, it was 3x squared minus 3. That was our gradient function. So we use that one to fill our table. So when we fill our table, we replace the value of x with 0 for this case. So 0, when we replace here, it will be 0 minus 3. It will be 3 into 0 squared minus 3. So 0 minus 3 will give us negative 3. We also replace with the 2. We say that 3 into 2 squared minus 3. So it will be 4. 4 times 3, 12 minus 3. It will become 9. Then here we also fill the table using the same derivative function, 3 into negative 2 squared minus 3. Therefore, here we say this one is 4. Here it will become 9. Then we have 3, 0 squared minus 3. It will become negative 3. Students, after filling the table, we move on to what we call the derivative. We move on to what we call stating the nature by sketching. Now, here it is coming from the negative side. So negative is coming from the negative through 0 to the positive. So this is what we call minimum. 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 This is coming from the positive through 0 to the negative. Nobody's at the upstairs, so we say it is maximum. That's how we state the nature. We have only 3 natures. We have others where we have from the negative through 0 towards the negative. It's called point of inflection. Where we have here negative, we also have here negative. So it is called a point of inflection. Now students, we've come almost to the end of our lesson. But what is crucial here to understand is that when you want to sketch and state the nature, you use the gradient function, but not the real equation. Dear students, we've just come to the end of this lesson. Like, subscribe, and it will be well with you so that we will get the next lesson where we will be talking about application of this differentiation in kinematic. Thank you for listening to me. Thank you very much. Let us meet in our next lesson.